Hey guys, we're back with section 6.4, day 2. So again, all you had to do yesterday was watch the videos about how you create the graph of the sine and cosine function. So I've basically rewritten an important summary as to what the sine and cosine graph looks like for one cycle or one period. All right, some of the biggest things to take away is that we know that the period for each function is 2 pi radians. It takes from 0 to 2 pi to create one cycle or one period or one sine wave or one cosine wave. Okay. Oh, my marker's not working. Okay, so we know their amplitude is 1. From highest to lowest, it goes from 1 to -1. So again, that means if you kind of look at that midline right here, it's 1 unit up and 1 unit down. All right, it's half the distance from the highest and lowest point. Okay, same thing for the cosine. It's 1 to -1. All right, that is their amplitude of 1 unit. Okay, they have a domain of all real numbers. You can plug any angle into either function and you'll get some type of ratio out. The range is from -1 to 1 on both graphs. That means the ratios or the y values that come out of these functions is always a number in between -1 and 1. And again, all of this information is before you've transformed it. You start transforming these graphs and stretching them or shrinking them or shifting them, and this information will change. But in their pure form, this is the basic information, okay? The major difference is to recognize them. The sine wave starts at 0, 0. The cosine wave starts at 0, 1. So that's one of the biggest things that you can use to kind of determine, wait a minute, is this the sine wave or the cosine wave is where it starts. All right, so we've taken their period basically from 0 to 2 pi and we've chopped it into 4 sub-intervals. If you take the period 2 pi and divide it by 4, you get pi over 2. So that means every pi over 2 units, you create a key point. So 0, pi over 2, pi would be another pi over 2 units, 3 pi over 2, and then 2 pi, right? So really it's 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. Every pi over 2 units, you create a subinterval and a key point. So you should notice that it goes from 0, 0, pi over 2, 1, pi 0, 3 pi over 2, -1, 2 pi 0 are your 5 key points that live on the first cycle of the sine wave. All right, same thing. You take the cosines period, 2 pi, divide it into 4 subintervals, you also get pi over 2. So that means every pi over 2 units, you get a subinterval and a key point. All right, so you have 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. And each one of them creates a key point. You have the point 0, 1, pi over 2, 0, pi -1, 3 pi over 2, 0, and 2 pi 1. Those are the 5 key points that live on the cosine graph, okay? All right, so the transformations that we deal with first are the most basic transformations. They are vertical and horizontal stretches and shrinks. So that means that we're not shifting the graph anywhere yet. We're not shifting it up or shifting it down or shifting it right or shifting it left. We're just stretching or shrinking them by either multiplying or dividing the y values or multiplying or dividing the x values. Those are the transformations that we will see first. All right, so those transformations look like this form. Y equals A times the sine of omega x, or y equals A times the cosine of omega x. And this is what causes those vertical or horizontal stretches or shrinks, right? Because we're multiplying or dividing the y and x values. So the A that's on the outside of these functions, who does he really multiply? He multiplies the y's. So it's always going to be the y values times that A value. So whatever you do to the y's is going to affect that amplitude, that highest and lowest point that your graph reaches. So whatever you multiply the y's by, you're also multiplying the amplitude by that value. All right, well, since the amplitude is 1, if you multiply 1 by that A value, that means that your amplitude is going to be A, but it's always described as a positive number, so the amplitude is always the absolute value of A. So if this was a 2, that would be 2 times the y's. That means the y values would have gotten 2 times as big. So that means the amplitude would have gotten 2 times as big. So whatever you do to the y values, multiplying or dividing y's, you do that to your amplitude as well. All right. Now, if you're going to take the x values and times them by omega, well, we know the opposite effect always happens to the x's. So if this is omega times x, then what you're really doing is taking your x's and dividing them by omega. Well, your period is tied into your x values. It's the number of x values before it starts to repeat. So if you're going to multiply or divide your x values by something, then that's going to change your period as well. So your new period, you have to take 2 pi, your original period, and divide it by omega as well. And that'll be the new period of this transformed graph. So your period is always the original period divided by omega, okay? All right, so what I'm gonna do today is I've printed out some problems from your homework. And I'm just gonna run through some examples as to what your homework questions are gonna look like. And you guys can skip through and come back and look at as many problems as you need, all right? All right, so look at it, number 1. It says, determine the amplitude and period of the following function without graphing. So y equals 2 times cosine pi x, right? Well, this 2 on the outside, who's he really multiplying by 2? The x's or the y's? The y's. So that means it's 2 times the y's, which therefore it's gonna be 2 times the amp. Now again, we always want this number to be positive, so it's gonna be the absolute value of the original amplitude, 1, and then times it by 2, what you times your y's by, and who's your new amplitude going to be? What's the absolute value of 1 times 2? It's 2. So now your new amplitude is 2. So that means your height of your graph has gotten 2 times as big. It's going to go 2 units up and 2 units down now from that midline. All right, well, your period they're calling t. Well, think about it. What happened? In here, it says you're taking the x's and timesing them by pi. Well, we know we would take the x's and divide them by pi. So whatever I do to my x's then, I have to do to my period. That's going to affect my period. So take your 2 pi, your original period, and also divide it by pi. Whatever you do to the x's, you want to do to your period. So if you take the original period, 2 pi, and divide it by pi, what are you left with? You're left with 2 as well. So now your new period, the number of units it takes to create one cosine wave is only 2 units. It used to take 2 pi, which is about 6.28 units to create one cycle. Now it only takes 2 units. You've shortened the amount of time it takes to create one cosine wave. So now your period is 2. So technically, whatever you divide the period by, we divided it by pi, right, which is about 3.14. That means in one old period, 2 pi units, that means you're going to be able to create 3.14 cosine waves from 0 to 2 pi. That's what you're actually doing, okay? All right, let's look at the next one. Determine the amplitude of the following function without graphing. So same type of question, right? So y equals 4/3 times the sine of negative 2 pi over 3 times x. Well, that's a problem. Our book doesn't like you using a negative argument. And your argument is whatever you're taking the sine of, which is negative 2 pi over 3 times x, they don't want this to be negative. So we use one of our identities to rewrite it. So remember, the sine function is odd. So the sine of negative theta equaled negative sine theta. So I can take that negative out and put it on the outside in front. So this actually gets rewritten as y equals negative 4/3 times the sine of positive 2 pi over 3 times x. And this is the one you actually want to work with, okay? So they want the amplitude and period of this transformed sine graph. Well, think about it. This negative 4/3 on the outside. Who does he really times by negative 4/3? The y values, right? This is negative 4/3 times the y's. So that causes 2 things. It causes the y values to get 4/3 bigger than they used to be, and that negative sign causes an x-axis reflection, right? So if you're going to times your y's by negative 4/3, then therefore you automatically times your amplitude by that as well. That's negative 4/3 times the amplitude. But we want that to be a positive number. So it's going to be the absolute value of negative 4/3 times the original amplitude, which was 1, and that's going to be positive 4/3, right? The absolute value of that number, or I should say here, the absolute value of this number is always your amplitude. So that means your amplitude is 4/3. thirds. All right, what about your new period? Well, think about it. Whatever you did to the x's, if you multiplied or divided the x's by something, that's going to affect your period, the number of inputs it takes to repeat. So look here. Right now it's saying you took 2 pi over 3 and times them by x. Well, we know the opposite actually happens. So you actually take your x's and divide them by 2 pi over 3, which means you then have to take your period, which was 2 pi, and divide it by 2 pi over 3, right? So I'm just going to times by his reciprocal, 3 over 2 pi times 3 over 2 pi. The 2 pi's cancel, and you're just left with 3. So that means your period is now 3 units. Right? It used to take 2 pi units, 6.28 units to create one, sine wave. Now it only takes 3 units to create one sine wave. That means you can, whatever you divided your period by, 2 pi over 3, that means this is the number of sine waves that you can create in one old period of 2 pi units. All right, perfect. Okay, let's look at the next one. Now they want you to match the graph, it says. Match the function y equals 7 times sine pi over 9 times x to the correct graph. So multiple choice, right? Well, let's see. I'm working with a sine graph. So if you remember, in his original form, y equals sine x, right? Just a quick sketch, it would have started at 0, 0, would have went up, down, and back from 0 to 2 pi, right? It started at 0, 0, and it goes to 2 pi to create one sine wave. And it went from 1 to -1. That's what the original graph would have done. So let's see. Who are you really timesing by 7 in this transformed sine wave? Well, it's on the outside. So it's 7 times the y's, which means you have to take your amplitude and times it by 7 as well. So that's 7 times the amplitude as well, which is going to be the absolute value of 7 times 1. So that's 7. So you're looking for an amplitude of 7. So which wave now goes 7 up and 7 down from that midline? Well, let's look. This one goes up to 9 and down to -9. So he's out. He's not a correct option. This one also goes up 9 and down to -9. That's not a correct option as well either. All right. Now, also, this one you could have counted out as well because this is not a sine wave. It didn't start at 0, 0. It started at 0, 9, which definitely in these forms of transformations before we shift up and down couldn't have been a sine graph. All right, so that leaves this one and this one, right? So who's who? You should already know the answer because this one doesn't look like a sine wave when it starts up there, but let's figure this out all the way. So it says you took your x's and times them by pi over 9, which we know the opposite would have happened and we would have divided the x's by pi over 9, right? So that means you also would have had to do that to your period. So take your period and divide it by pi over 9 as well. So take, am I on the graph? Yeah, on the screen. So take 2 pi, the original period, and divide it by pi over 9. So I'm going to times by 9 over pi to clean that up. Times by 9 over pi. My pi's cancel. 2 times 9 is 18. Your new period is 18 units. So it's going to take 18 units to create one sine wave. So look, right, this one starts at 0, 0, so it could be a sine wave. It goes up to 7 and down to -7. It's got the correct amplitude, and it goes from 0 to 18 to create one sine wave. That's your graph right here. It's got to be C. And again, the dead giveaway here should have been, this is not a sine wave. If it didn't start at 0, 0 and it started at 0, 7, that's a cosine graph. That looks like this graph. If this had said cosine, this would have been the answer. Okay? All right. Let's look at another example. Look at number 4. Number 4 says, it's another matching graph. Match the given function to one of the graphs. So y equals -5 sine of 2 times x, right? Well, I don't have a negative argument, so I'm good to go. I can leave it the way it is. So let's see, this -5. Well, first of all, I'm sorry, I jumped the gun. I'm doing sine again, right? So again, I like to get a picture from 0 to 2 pi. My sine graph would have looked like that, right? Going from 1 to -1, just to kind of give myself an original picture as to what it looked like. All right, well, who's getting times by -5, right? The y values on the outside. So that would have been -5 times the y's, and then it also would have been -5 times the amplitude, which would have been the absolute value of -5 times 1. So now your new amplitude should be 5. So it should go up to 5 and down to 5. Well, let's see. This one, 5, 5, 5, 5. All right, they're all going to 5 to 5. Now, you can start ruling some out because this one has an x-axis reflection. If you're timesing it by a -5, it's going to make the y values 5 times as big, and it's going to cause that x-axis reflection. So that means if this gets reflected over the x-axis, it should go down and then up. That's what it would look like if you reflected it over the x-axis. So this one, it didn't look like it started at 0, 0. I'm going to say that's cosine, right? This one started at 0, 0, but it went up and then down like normal. So again, these two should be out. Now this one didn't start at 0, 0, so that's not looking like a sine graph. So he should be able to be out, and by process of elimination, it should be D. But let's finish it. Look at it. It starts at 0, 0. It's going to go down to -5 and up to 5, and then it's going to stop at pi. As long as my period is pi units to take one sine wave, this is definitely our graph. Well, what's our new period? Well, it looks like you took your x's and times them by 2. So we know we would have done the opposite and divided them by 2. Then we would have had to take our period and divide it by 2 as well. So what's 2 pi, the original period, divided by 2? It's pi. So it takes pi units to create one sine wave. And that's exactly what this graph does here. To create one reflected sine wave, it took pi units. So the answer is definitely D. All right? Look here. All right, in number 5, they're going to ask you to create a graph. Well, guys, it's a graphing tool. You just have to click on the right buttons. So if you want to graph this, right, y equals negative sine x. Well, first things first, we don't like negative arguments, right? So we're going to rewrite that because it's the sine of negative theta equals negative sine theta is our identity, right? You can pull that negative out and put it on the outside because it's an odd function. So really it's going to be y equals negative sine of 6x. Okay, so let's see what's going on here, right? So it's a sine wave. So the first thing you would want to do is when you open up your little online graphing tool is click the sine wave. There's either going to be a cosine wave to click on or a sine wave. Either they'll give you this button to click on or they'll give you this button to click on. That's the cosine and that's the sine. So you want to click on the sine one. So click on the sine wave because that's who we're graphing. Now to get started, you got to click on a button. Well, where does the sine wave start? At 0, 0. So I always click on 0, 0. And then you should see a sine wave pop up on your graph. But now you have to transform it, right? Well, think about it. This -1 on the outside really times is who by -1? The y's, right? So that's -1 times the y's, which isn't going to change our amplitude because it's still timesing by a 1. Because it's the absolute value of it, but it's going to cause an x-axis reflection. So now your sine wave should be going down and then up. It should be doing that, okay? All right, but again, it's going to do it all for you. All you have to do is click the x-axis reflection button or box. Okay, because that little transformation gray box is going to pop up like it normally does. You want to click the x-axis reflection box, okay? All right. And then what else did it ask for? Oh, 6 times x, right? Well, really that means we would have taken the x's and divided them by 6. So take your period and divide it by 6. So 2 pi divided by 6 becomes pi over 3. So now your new period is pi over 3. So they might have you type in a box. I think they're going to have you type in the period. You would literally type in pi divided by 3 as your new period in the period box. All right, and then the amplitude box, it would be -1 times 1 and the absolute value of it, right? Because it's -1 times your amp as well. So the amplitude would still be 1. And you would just put 1 in the amplitude box. And the minute you make these changes, changing the amplitude to 1, your period to pi over 3, your graph should automatically pop up, okay? And then you literally just hit save, and that's all you have to do, okay? All right, so again, in this case, all you're doing is if I'm taking the period 2 pi and dividing it by 6, that means you should be able to get 6 sine waves from 0 to 2 pi. And they should be inverted, so it should be like really kind of compressed. Really small graphs like that. And again, you should get 6 of them before you get to 2 pi. That's what your graph should look like. But it's going to do it for you, okay? All right, perfect. What's up, bud?
There's a spider downstairs.
Was it a big one?
Yes. It was like this size.
Oh, Zach, don't. I don't want to know. Sorry, my son just told me that they found a spider in our basement. Okay. All right, next question. All right, number 6. It looks like 6 and 7 are more graphing ones, so I'm just going to skip them because that's just going to be the exact same thing as these ones. And just text me if you have any questions, okay? All right, let's look at number 8. Okay. All right. Oh, wait, guys, sorry. This one I think asked, I didn't answer the question. In number, where was it? 5? Yeah. They also asked for the domain. Well, who's your domain still going to be? It's going to be all real numbers. But now your range is going to be what? Well, your amplitude. Did your amplitude get changed? No, not in this case, right? Because it was that -1 out in front, so your amplitude was still 1. So your range is still going to go from 1 to -1. Okay? If your amplitude changed, then your range would have changed, okay? All right. Yeah, number 8. All right, this one says, write the equation of a sine function that has an amplitude of 3 and a period of 6 pi. So guys, remember, these are the types of transformations that we're working with right now, causing these vertical and horizontal stretches and shrinks. So your new equation that you're writing should look something like this, right? You're going to put something in for A if the amplitude changed. You're going to put something in for omega if the period changed, okay? All right, well, let's look. You get multiple choice options. There are 2 equations. The equation if omega is less than 0 or omega is greater than 0. Well, we didn't usually work with a negative argument. We always pulled that out using identity. So omega shouldn't be 2 options. He should just be that positive number. There's only one equation, and it is this, or there are 2 equations, one where the amplitude could have been less than 0, or one where the amplitude could have been greater than 0. And I say amplitude, I shouldn't say amplitude, that A value, right? Because the amplitude is always positive. But the number that was in front could have been positive or negative because we take the absolute value of it. So it should be option C. There should be 2 options as to what this equation could have been. All right, so think about it. Well, it says write the sine function. So we're going to deal with y equals a times sine times omega x. That's our job. Okay. Well, if we have an amplitude of 3, what should a have been? What would a have been if your amplitude is 3? If the amplitude is 3, this should have been a 3, right? Because whatever you multiply your y's by, that becomes your new amplitude. But it could have been a positive or a -3. So that means that your a value could have equaled plus or minus 3. So now we're looking at y equals plus or minus 3 times the sine of, well, what would omega had to have been if your new period is 6 pi? Well, think about how you get your new period. You would have taken your old period, 2 pi, and divided it by omega, right? And then that would have had to end up equaling your new period, which is 6 pi. So now you have to figure out what would omega need to be in order to divide 2 pi and end up with 6 pi as your answer. So guys, make this a proportion. Cross multiply. I'm going to get 2 pi equals 6 pi times omega. And now solve for omega. Divide by 6 pi. Divide by 6 pi. And you get 1/3 would have been omega. So that means it would have been y equals plus or minus 3 times the sine of 1/3 would have been your omega times x. And that could have been the equation that you had in order to get an amplitude of 3 and a period of 6 pi. So you would say if a was a number less than 0, then that would have been the y equals -3 times the sine of 1/3 x would have been one option. And then there would have been the equation where a was a number greater than 0, which would have been the positive 3. So y equals positive 3 times the sine of 1/3 x. Okay? All right, let's try that one again. So look here. Look at number 9. Write the equation of a sine function again that has to have an amplitude of 3 and a period of 7, right? So we're doing sine. So we need to use this guy right here. That's what we would have to end up being. So who does our a value have to be in order to end up with an amplitude of 3? Well, a could have been plus or minus 3 again, right? So there's two options because in order to get the amplitude, you have to take the absolute value of that number right there. So it leaves you with two options, all right? And then your period is 7, right? So who would omega had to have been to end up with a new period of 7? Well, we would have taken the period, 2 pi, and we would have divided it by omega, and that would have had to end up equaling the new period of 7. So cross multiply, you would get, put it over 1, you would get 2 pi equals 7 times omega. Solve for omega by dividing by 7, and you would get 2 pi over 7 is your omega. So that's what you would have multiplied x by in order to end up with 7 as your actual period. So again, there are two equations where omega could have been negative or positive. Nope, because we don't work with a negative argument. So omega shouldn't be two options. He should just be one option. So it's not that, right? There's only one equation. No, there could have been two because that could have been a positive or a negative number to end up with an amplitude of 3. All right, so there are two options. One equation could have been where a is a number less than 0, so he was negative, so that would be the negative 3. So y equals negative 3 times the sine of omega was 2 pi over 7 times x. Or it could have been an equation where a was a number greater than 0, so y equals positive 3 times the sine of 2 pi over 7 times x is your other equation you could have written. Okay? All right. Let's look at another question. That was 9. I think I'll do one more, and then I'll stop. And then you should have enough to kind of get through your homework problems. All right, it says, find an equation for the graph shown to the right. So guys, look at this graph. First of all, it's either going to be a sine transformed vertically or horizontally stretched, or a cosine wave. Well, look at the graph they've given you, right? This graph is not shifted right or left or up or down yet. So if it starts at 0, 0, it's going to be a sine wave. If it starts up at 1, it's going to be, or I should say not 0, 0, because maybe it was the amplitude was changed. But if it doesn't start at 0, 0, then that should be cosine. So right now, the fact that it starts at 0, 0 and it goes up and then down like normal, this is a sine wave that has not been reflected over the x-axis. So we should be writing one for like that, okay? All right, well, let's see. Look at your amplitude. It goes up to 3/4 and it goes down to negative 3/4. That's your amplitude. From your midline, it's going up to 3/4 and down to negative 3/4. So you clearly have an amplitude of 3/4. Now, because it went up and then down, we're physically looking at the graph, it was not reflected. It did not go down and then up. So I know that A must have been a positive number to not cause that x-axis reflection. So that means A must have been greater than 0. So that means A equals positive 3/4, not negative 3/4. So now I know my equation is looking like this. Y equals positive 3/4 times the sine of, well, who's my omega? Well, guys, look at the time it takes to create one sine wave. I go up, I go down, I'm back where I started, right there. It took 2 units to create one sine wave. So your period is now 2. So think about it. What did you have to do to your original period to get your new period of 2? Well, we would always take 2 pi and divide it by omega, right? That's how we would get our new period. So our new period has to be 2. So let's solve this. Cross multiply. 2 times omega equals 2 pi. Divide by 2. And that means omega must have been pi. You must have multiplied the x's by pi to get a new period of 2 units. So this must have been the equation that created that graph. Perfect. All right, so that would have been your answer right up there. Okay. All right. Should we do one more? Let's try it. I know I was going to stop, but this one's a little bit different and it's got a reflection. All right, so look here. So they said find the equation either of this form or this form. So let's first determine whether we think this is a sine or cosine wave. Well, guys, think about it. If it was sine, even if it had been vertically stretched up or down, it still would have started at 0, 0. And this one doesn't. This one starts at 0 some numbers. Well, 0, -1. So it's clearly cosine. So that's the graph or equation we should be writing, right? But if you notice, the original cosine started at 1, came down, and then went back up. This one starts down here and goes up and comes back down. This has an x-axis reflection. This has been reflected over the x-axis, which means that A value out front must have been what? It must have been negative. All right, so that means A must have been less than 0. Well, look at your amplitude, guys. It goes from 1 to -1. So the amplitude didn't actually change. It's still going from 1 to -1. So that means that cosine must have been times by a -1. If it had gone to 2 and -2, then it would have been a -2. But because it still goes from 1 to -1, it must have just been times by -1. All right, so we're looking at y equals negative times the cosine of, what is my omega? Well, guys, let's look. It takes what? To create one cosine wave, we're a little bit upside down. It goes up, it comes back down. We're back to where we're started right here at 10 pi over 9. Your new period is 10 pi over 9. What was omega in order to create that new period? Well, think about how you would have found it, right? You would have taken 2 pi and divided it by omega to get that new period, 10 pi over 9. So cross multiply, you would get what? 10 pi omega equals 18 pi. So divide by 10 pi to solve for omega, and that means omega equals, am I even on the screen? Yes. All right, well, pi's cancel. 18 over 10, what? Both divide by 2, that would be 9 over 5. So omega must have been 9/5. So that means you would have done 9/5 times x. And that would be your new actual equation for that graph. Okay? All right, perfect. All right, well, listen, I hope that helps. Always go back to what the original one looked like. What was the original amp? What was the original period? And then look for all the clues that you can use. All right, please text me if you have any questions on the homework. All right, good luck.